Welcome to BioPrime Health, where we transform scientific research into practical protocols for optimal human performance. Today we are exploring one of the most powerful adaptogenic herbs ever discovered, Rhodiola rosea. While you may have heard this plant mentioned alongside other adaptogens, the research reveals Rhodiola stands in a category of its own, with a unique biochemical profile and documented effects that surpass many other natural compounds for specific applications. For thousands of years, Rhodiola thrived in obscurity, growing in the harshest high-altitude environments of Siberia, Scandinavia, and the Arctic regions, where it developed remarkable biochemical defense mechanisms to survive extreme conditions. These same compounds, when properly extracted and administered, demonstrate profound effects on human physiology, particularly in the domains of cognitive function, stress resilience, energy metabolism, and physical performance. Traditional folk medicine recognized Rhodiola's value centuries ago, with Vikings reportedly using it for physical stamina, Siberian hunters carrying it on extended expeditions, and Chinese emperors dispatching expeditions to the Altai Mountains specifically to obtain this golden root. But what does modern scientific research actually reveal about this remarkable plant? Today, I'll share the comprehensive analysis of Rhodiola's bioactive compounds, evidence-based applications, optimal dosing protocols, and sourcing criteria that separate truly therapeutic products from ineffective commercial imitations. The primary bioactive compounds in Rhodiola rosea include rosavins, rosavin, rosin, and rosarin, and salidroside, rhodioloside, with standardized extracts typically containing 3% rosavins and 1% salidroside, reflecting the naturally occurring 3:1 ratio in the plant. This specific ratio proves critical, as research published in Phytomedicine demonstrates. The entourage effect between these compounds creates significantly greater bioactivity than isolated constituents. Gas chromatography mass spectrometry analysis has identified over 140 compounds in Rhodiola rosea, including phenylpropanoids, phenylethanol derivatives, flavonoids, monoterpenes, triterpenes, and phenolic acids. However, the rosavins are unique to the Rhodiola rosea species specifically, distinguishing it from other Rhodiola species with different phytochemical profiles and effects. This specificity makes proper identification and sourcing absolutely critical, as studies in the Journal of Agricultural and Food Chemistry reveal that approximately 30–40% of commercial Rhodiola products contain different species, like Rhodiola crenulata or Rhodiola quadrifida, which lack the signature rosavin compounds. The most extensively researched effect of Rhodiola relates to its classification as an adaptogen, a compound that helps the body resist a wide range of stressors. The molecular mechanisms underlying this effect have been documented in remarkable detail. Research published in the International Journal of Psychiatry in Clinical Practice demonstrates that Rhodiola extract modulates stress response by balancing the hypothalamic-pituitary-adrenal axis through multiple mechanisms. Specifically, it regulates cortisol secretion patterns, preventing both excessive release during acute stress and the depleted cortisol syndrome often observed in chronic stress conditions. A double-blind, placebo-controlled study involving 118 individuals with stress-related fatigue showed that Rhodiola extract, 576 milligrams daily for 28 days, significantly reduced cortisol response to stress testing while improving self-assessed stress symptoms by 45% compared to just 10% in the placebo group. Even more fascinating, research in experimental neurology reveals Rhodiola's ability to increase stress resilience through neuroprotective mechanisms, with salidroside specifically shown to upregulate stress-protective heat shock proteins, HSP70 in particular, that defend cellular structures against damage. This mechanism creates what researchers term a stress resistance buffer that operates regardless of whether stressors are physical, emotional, or biochemical, explaining the herb's remarkably diverse applications. For cognitive enhancement, Rhodiola demonstrates equally impressive research validation. A systematic review published in Frontiers in Pharmacology analyzing 36 studies found consistent improvements in cognitive function, particularly in attention, processing accuracy, and reaction time. The molecular basis for these effects appears multifaceted. Research in molecular neurobiology demonstrates Rhodiola regulates key neurotransmitters by inhibiting the enzymes monoamine oxidase A and B, MAOA and MAOB, and catechol O methyltransferase, COMT, effectively increasing the availability of dopamine, serotonin, and norepinephrine in the brain, neurotransmitters critical for focus, motivation, and cognitive processing. Additionally, electron microscopy studies reveal rhodiola increases synaptic vesicle formation and neurite outgrowth, promoting healthier neural networks and enhanced plasticity. Particularly notable is rhodiola's ability to improve cognitive function under stress. A randomized controlled trial published in Planta Medica involving night shift physicians demonstrated that those receiving rhodiola extract, 170 mg daily, maintained significantly higher scores on cognitive performance tests during their shifts compared to placebo, with the most pronounced differences observed at the 2-3 a.m. period when fatigue typically peaks. For physical performance, multiple clinical studies support rhodiola's ergogenic effects. Research published in the Journal of Strength and Conditioning Research demonstrated that athletes taking rhodiola extract, 340 milligrams daily for 4 weeks, showed significant improvements in time to exhaustion, peak power output, and perceived exertion during high-intensity exercise testing. The mechanisms behind these effects extend beyond simply increasing energy. Studies using muscle tissue biopsies reveal rhodiola increases ATP synthesis in mitochondria while simultaneously upregulating the expression of glucose transporters, GLUT1 and GLUT4, effectively enhancing both energy production and the delivery of glucose to working muscles. A particularly fascinating mechanism involves rhodiola's ability to modulate the AMP-activated protein kinase, AMPK pathway, a fundamental energy sensing system that regulates cellular metabolism. Research in the Journal of Physiology and Biochemistry demonstrates that specific compounds in rhodiola activate AMPK in a manner that mimics the cellular adaptations typically observed after endurance training, essentially signaling the body to enhance its metabolic efficiency. For inflammation modulation, rhodiola demonstrates selective effects that distinguish it from many natural compounds. Rather than simply suppressing inflammatory pathways broadly, which can impair important immune functions, research in immunopharmacology and immunotoxicology shows rhodiola normalizes inflammatory responses, reducing excessive inflammation while supporting normal immune surveillance. Specifically, salidroside has been shown to inhibit the nuclear factor kappa B, NF-κB pathway only when it's pathologically activated, without compromising its normal function in healthy cells. This selective action makes rhodiola particularly valuable for addressing chronic low-grade inflammation that often underlies fatigue states and cognitive impairment. Beyond these core mechanisms, emerging research points to rhodiola's potential neuroprotective effects. Studies in the Journal of Ethnopharmacology demonstrate that salidroside specifically protects neurons against oxidative stress by activating the NRF2 pathway, the master regulator of antioxidant response. This activation triggers the expression of critical neuroprotective enzymes, including superoxide dismutase, catalase, and glutathione peroxidase, effectively creating an enhanced cellular defense system. Furthermore, research in phytotherapy research shows that rosavins appear to enhance cerebral blood flow by promoting nitric oxide production in cerebral blood vessels, potentially improving oxygen and nutrient delivery to brain tissue. For optimal dosing, clinical research consistently shows the greatest therapeutic effects with standardized rhodiola rosea extract containing 3% rosavins and 1% salidroside administered at doses between 200-600 milligrams daily. Lower doses, 200-300 milligrams, appear optimal for cognitive enhancement and daily stress management, while higher doses, 400-600 milligrams, show greater benefits for physical performance and acute stress resilience. Timing proves particularly important with rhodiola, as research in pharmacological research demonstrates its effects follow a reverse U-shaped dose-response curve, where benefits increase up to an optimal dose but then decline with excessive amounts. Multiple studies confirm that single morning dosing provides superior results compared to multiple daily doses, likely due to alignment with natural cortisol rhythms. Taking rhodiola approximately 30 minutes before breakfast on an empty stomach significantly enhances absorption of its key bioactive compounds. For optimal absorption, look for products using root extract rather than whole root powder, as the concentrated extract ensures therapeutic levels of active compounds reach the bloodstream. Clinical effects typically appear within 3 to 7 days for acute stress and cognitive applications, while full adaptogenic benefits develop more gradually over 30 to 40 days of consistent use. Rhodiola demonstrates excellent safety, with systematic reviews showing minimal side effects even at doses substantially higher than therapeutic recommendations. For long-term use, research supports cycling protocols with 8 to 12 weeks of use, followed by 2 to 3 weeks off to prevent receptor adaptation. Quality sourcing remains perhaps the most critical factor for achieving therapeutic effects with rhodiola, as geographic origin dramatically affects phytochemical composition. Research published in Phytochemical Analysis demonstrates that rhodiola grown in high-altitude Arctic regions, particularly Siberia, northern Scandinavia, and Tibet, contains significantly higher concentrations of rosavines and salidroside compared to the same species grown at lower elevations or warmer climates. This results from the plant's response to environmental stress, where harsh conditions trigger increased production of protective compounds, precisely the constituents responsible for therapeutic effects. Beyond geographic origin, harvest timing significantly impacts potency. Research in the Journal of Food and Drug Analysis shows optimal bioactive compound concentration occurs when rhodiola roots are harvested after at least 4 to 5 years of growth, and specifically in early fall after the flowering period. Wild harvested rhodiola generally contains higher bioactive compounds than cultivated sources, though sustainable wild harvesting has become increasingly rare due to over-harvesting concerns. Look for products that specifically state Rhodiola rosea, not simply rhodiola, and verify standardization to 3% rosavines and 1% salidroside, as these precise ratios match the composition used in clinical research. Products should specify geographic origin, with Siberian, Arctic, or Altai sources generally providing superior phytochemical profiles. Among the most extensively studied commercial extracts are SHR5, used in many clinical trials, and Rhodiolife, both developed based on the traditional Siberian extracts. Several specific applications of rhodiola deserve particular attention based on clinical research. For cognitive performance during sleep deprivation or jet lag, research published in Aviation, Space, and Environmental Medicine demonstrated that 370 milligrams of rhodiola extract taken twice daily significantly preserved cognitive function and reaction time in individuals experiencing acute sleep disruption. For burnout and chronic fatigue recovery, a multi-center clinical trial published in Neuropsychiatric Disease and Treatment showed that healthcare workers with burnout who received 400 milligrams of rhodiola extract daily exhibited 36% reduction in emotional exhaustion and 42% improvement in work performance measures within 12 weeks. For altitude adaptation, research in wilderness and environmental medicine revealed that mountaineers taking rhodiola extract, 600 milligrams daily beginning 5 days before ascent, showed significantly better oxygen saturation, reduced acute mountain sickness symptoms, and improved exercise capacity at high elevations compared to control groups. For students during examination periods, a double-blind, placebo-controlled study published in Phytotherapy Research demonstrated that those taking rhodiola extract, 100 mg daily for 20 days, showed 8.4% higher average exam scores and reported 50% less mental fatigue during the examination period compared to the placebo group. Particularly notable is rhodiola's potential synergy with specific compounds. Research in phytomedicine demonstrates enhanced effects when rhodiola is combined with Schisandra chinensis for physical performance, with Eleutherococcus senticosus for stress resilience, and with B vitamins, particularly B1, B6, and B12 for cognitive function. However, research also indicates potential pharmacokinetic interactions with certain medications metabolized by cytochrome P450 enzymes, highlighting the importance of professional guidance when combining rhodiola with pharmaceutical medications. To implement rhodiola into your health optimization protocol, begin with a 2-week loading phase using 400 to 500 milligrams of standardized extract, 3% rosivins, 1% salidroside, each morning on an empty stomach, followed by a maintenance dose of 200-300 milligallons daily for cognitive and stress benefits, or 400-600 milligallons for intensive physical training periods. Maintain consistent daily use for at least 30 days to experience the full adaptogenic benefits, while recognizing that acute cognitive effects often appear within the first week. For peak cognitive performance during high-demand periods, consider temporarily increasing to 500 to 600 milligallons daily, returning to maintenance dosage afterward. Rhodiola represents one of the most extensively researched adaptogens, with applications ranging from everyday stress management to enhanced cognitive performance and physical optimization. What distinguishes rhodiola from many natural compounds is the exceptional depth of scientific validation, from detailed molecular mechanisms to multiple large-scale clinical trials, consistently demonstrating meaningful effects on human performance. When sourced appropriately and administered according to evidence-based protocols, this remarkable plant offers significant benefits for individuals seeking to optimize their cognitive function, stress resilience, and physical performance in our increasingly demanding world. In our next video, we'll explore advanced protocols for naturally optimizing testosterone through targeted nutritional and lifestyle interventions. If you found this information valuable, subscribe to BioPrime Health for our continued exploration of evidence-based health optimization. This is BioPrime Health, where science transforms potential into performance. Have you experienced benefits from rhodiola or other adaptogens? Let me know in the comments below.